Good afternoon. Yes. My name is David Schmudde. Thanks for joining me after lunch, first talk after lunch. Hopefully you enjoyed the meatballs. I hear they were good. I did not participate. So today we're going to talk a lot about actually engineering, even though ostensibly this is about artists. But the two can benefit a lot from one another, and so that's the topic I want to explore with you today. I'll try to leave enough time for the Slido questions at the end. We'll see. We have a lot to cover today. So yeah, my name's David Schmudde, and I want to talk about pipes. Well, kind of. Some of you that are familiar with the arts or have been around the arts for a while, of course, will probably recognize the image on the left, the Rene Magritte image, captioned, the painting captioned, "This is not a pipe." The image of the right came from an image search that I got off the web last night, and it's just a pipe that you can buy. I didn't check how much it costs, but if you're in a room with both of these things, of course, you can imagine looking at both of them, the painting and the pipe. And the pipe, we know, of course, its purpose. The pipe is there as a way for you to take in tobacco, right? And in fact, that technology of the pipe has actually become more and more advanced. I've seen people vape, actually, even at this conference, right? So it's something with a purpose that we can define, we can point at and say that's the purpose of that thing. Of course, it's kind of decorative, it's kind of beautiful, but it has a purpose. And if it fails to meet that purpose, we say it's broken. Right? The purpose on the thing on the left is a little bit more unclear. It's a painting, and again, you're in the room with it, and the paintings don't break or anything. And what is it there for? Is it there to provoke you? Is it there for your amusement? Okay, I mean, it's pretty relative, right? And of course, then there's this like meta-narrative on that image where it says this is not a pipe, because of course what Magritte was saying is that this is not a pipe, this is an image of a pipe, so it is a tautology as well. So it brings us to this question that I've worked in art for a long time and technology as well, but as an artist, I get this question on occasion from non-artists, of course, and it's actually not a question that I find particularly interesting, because the question itself is the answer. What is art? It is unknowable. It is something, once you know it, its purpose is to subvert your knowledge. It will never be known. It will never be held. Okay, so the question itself is the answer. The question itself is the material of art. A more interesting question, and the one that we're going to be talking about today more, is what is technology? I mean, at least a more interesting question to me. A lot of people get this wrong, and I don't know if I'll have the answer today, but we'll actually know what the answer is not. So for example, that emoji next to what is technology, that emoji, the code for it is art. Okay? That is a painter's palette with paint on it. A painter's palette with paint is not art. Mona Lisa is the art, right? The palette with the paint is the technology. The palette with the paint is the technology, and technology allows artists to do certain things, and artists will use technology to stay ahead of the curve. Okay? Painting, for example, Rembrandt, right? Rembrandt isn't Rembrandt without the advance of painting technology. Jackson Pollock needed advancements in painting technology to pull off his paintings. Right? Hip-hop, for example, if you're not familiar with the painters, hip-hop, right? People have been saying poetry over rhythms since people have been speaking over rhythms. But hip-hop as we know it, hip-hop, the thing that sounds and we identify as hip-hop, doesn't happen without the drum machine. Okay? These are people relying on a certain technology. These are artists relying on a technology to advance their craft. And so art is often a technological endeavor. And artists are pretty good at this because artists, kind of it's in the job title, it's in the description at least. You've got to be creative, right? And a lot of these creative folks tend to be early adopters. They tend to be intellectually curious. And oftentimes they're subversive, they're subverting norms. I'm going to use the word subversive, misuse and subversive sort of interchangeably in this talk, right? And what they're subverting, maybe they're subverting something culturally, but oftentimes they're subverting a tool's intention. And as engineers, we make tools, right? We make tools that people use to online date, tools to word process, tools to do all sorts of things with their lives, right? And we build it with an intention built in. And if you're a person using that tool with the designer's intention, you're merely fulfilling that intention and you're not doing anything more, which is fine. It can be a creative act with that sort of approach. But a lot of times artists will take what is a screwdriver or what is a spreadsheet and they'll do something more. They'll use the tool beyond what the original person intended it to be used as. And that is a new manifestation. It expands the purpose of the tool. And you as the engineer, you see that, it comes back to you, and you see it used in new and novel ways. It's flattering. Sometimes they break it. Sometimes they make it worse, right? Sometimes you learn something from it. And that's one of the things that we're going to be focused on today. So this idea, though, that there are these two cultures is something that has been sort of in my bipolar sort of sense of self, I guess, for some time, where I have an engineer as a father and an artist as a mother. But these two cultures, the dichotomy between the two cultures don't just exist within sort of my lifetime. This is a book or lecture by C.P. Snow, Two Cultures in the Scientific Revolution. And what he was pointing out in the 1950s, what he was worried about at the time when he was giving this lecture, he was worried about this divide and the fact that as a person that is a writer and as a person that is a scientist, which he was seeing that his friend groups, they don't interact. So the scientists do their thing and the artists do their thing, and there's a fine line, and they don't have a lot of friendships across that border. And he said, this is dangerous. This is not a good state of being. He was very concerned about that in this lecture. And his example that he gave is this fact that, or at least in his experience, that his artist friends or his literature friends didn't know anything about, for example, the second law of thermodynamics. And it's not about like being an expert physicist. He's not asking for that, but he's asking for some awareness of the elegance and the beauty and what it means. Right? On the opposite side, he had a lot of scientist friends that weren't very well read, of course, and they weren't familiar with a single work of Shakespeare, and he said, this is a problem. These two people have a lot to exchange, these two groups of people, and they're not. And he expected that to have, of course, dire consequences as, of course, science becomes increasingly weaponized and advances faster than our capacity to sort of adjust what's happening. And part of why this happens is the fact that artists have often struggled for access to cutting-edge tools. So this right here is a map of the Ipsonet. This is not part of the internet. This was not part of the internet when it was built. This is a network of the 70s and 80s. It was built by IP Sharp Associates, and it's kind of hard to tell what's going on here, but the center here with all the lines coming out of it, that's Chicago, and then above it, that's Toronto, and across the channel, that's connecting to London, and over here, this is Australia. Okay. So it's this worldwide network. And it's a worldwide network for business people to travel and, of course, exchange information, right? And it was built for that purpose. There's this other word I have up here, Artex, and that stands for the Artist Electronic Exchange. And in fact, on Ipsonet, they set up within the corporate structure access for artists on this electronic exchange system, which was pretty unique at the time. Artists didn't have access to those tools necessarily, except for maybe at a university. And it was so primitive, to get an account, you had to walk into an actual physical office to actually get an account and log on. And we don't have a lot of records from that era. We do have this particular piece, and we're going to be looking at a number of different pieces today. This is the first one. This is Roy Ascott's La Plissure, the text, and it was a sort of a community-written story. There were 11 artists in different time zones all around the world, and they each had a character assignment, and they essentially crossed their cultural sort of boundaries to continue to add things to the story at assigned times, right? And so it was an exercise in sort of rapid iteration and whatnot. This is what it looked like. It's actually not a particularly good story. I've read a bunch of it, but there's some ASCII art in there and whatnot, in different languages. I don't remember what that means, but it's part of the story. And so, we get back to this idea of purpose and like what exactly we're getting from this, or what exactly IPSA.net is getting from this, like, not great story, right? Of course, like, IPSA.net, of course, was built for the purpose of making money. We know why that existed. Why they allowed artists on the network. I mean, that's beyond my sense of what's happening at the time. What possible sort of things could they get out of it? Well, there's like just playing around, misuse. So you have a thing and you're just seeing what you can do with it, poking at the edges, right? As an artist, as a creative experimenter. R&D. So maybe they had some sort of like far-flung R&D thoughts around the fact that the way we often communicate is through narrative, right? And if we have better narrative tools, then perhaps we can enable business applications. And of course, maybe having people work at the edges of a system will reveal things about the relief of the system, which is an engineering problem, and vulnerabilities of the systems, or problems with the systems. So these edge cases, as engineers, we get to these edge cases. Often we design for the edge cases. We try to think about them in advance. That doesn't work that well, but it's worth the effort for sure. We design tests also to catch those edge cases. And then at some point, someone's going to hack the system in some way, either for fun or for profit or whatever, or maybe even by accident. We're going to hope that it's white hat and not black hat. But that's how these systems kind of deal with misuse in a conventional sense. But artists have been misusing things at the edges, of course, very visibly for a long time, in creating value that is very demonstrable. So in that art text example, I really couldn't tell you what the value is of having a bad fairy tale being written on their particular network. But in this example, I live in New York. This is a very well-known example in New York City. This is Andy Warhol sitting in his original factory in Midtown. And throughout the last half of the 20th century, artists have been moving further and further out to the edges of New York because it's still inexpensive, right? At this point, Warhol was paying $100 a month for this space. And the space that was so undesirable, that it was $100 a month, ended up becoming a film studio, a print shop, a recording studio, a counterculture center. I mean, it became the factory. It became a hallmark, right? And slowly and surely, he moved out of that space. Midtown became unaffordable, okay? But it's not just Andy Warhol. It's Debbie Harry's Lower East Side. It's Basquiat's East Village. It's Williamsburg, Brooklyn, et cetera, et cetera. And what's happening there is these artists are pointing to a thing, and suddenly people are saying, oh, that thing actually is valuable. And you see it reflected in the city because the rents go up. All of a sudden, people are investing into maintenance and building new infrastructure in these parts of the city. So the artists were at the edges first, pointing to the value of the edge, that no one else was seeing, right? And now, try to get a place in Midtown. So, on this thought of edge cases and value, the early web is another Wild West place, like the 1960s edges of Midtown, right? This group, Jody, it's actually two people. They're still doing great work. This is one of my favorite pieces of theirs at www.jody.org. When you land on the site, this is what it looks like. I love this piece. And when you reveal source, this is what you get. The schematics for Fat Man and Little Boy. And as accurately as you can depict in ASCII art nuclear fission, right? And of course, there's a concreteness to this that they're pointing to. Okay, the bomb hits, right? The bomb hits, boom. That's the outcome, right? All that order becomes chaos. What we see is the chaos after the bomb hits. And that's kind of interesting. But to me, the thing that really makes this piece kind of great is the fact that it was built at a time the web value proposition was unknown. And artists were working at the edges, once again, and figuring out what the value is here. In this case, they're enabled by the fact that no one else knew what the value was of the web at the time. Someday we're going to shop for clothing on the web. I'll believe it when I see it, right? Someday we're going to put our credit card numbers in, all this other stuff. We had a sense, I mean, the web was being commercialized by this point, by 1995. We had a sense where it was going, but we didn't know exactly where it was going, right? And so when they were building these websites, of course, they made the decision, of course, to allow the source to be revealed. And that's because how valuable could the source actually be? Now, later on, when Apple gets involved and they make an app store, right? What do they decide? They decide, of course, as part of that app store, do they put in a reveal source? I mean, these are just web widgets, okay, internet widgets that are pulling information, right? No, of course they don't, because we knew what the value proposition was of that app store, and they took this different model, the model of boxed software coming off the shelf at computer stores, right? So it's just a different business model. It's a model where they knew the value in advance, though, right? So, okay. Looking at another piece from '95 with Jody, and I have a little trouble getting this one to work all the time, but we're lucky we got it going here. It's called Automatic Rain. This one had to be emulated in an old Netscape Navigator web browser because it doesn't actually work anymore in contemporary browsers. And it doesn't actually work in this browser very well either. Again, from 1995, you click on it, and it's hard to see here, it's a little washed out, but it's the blink tag, okay? And there's these blue numbers kind of raining down. It's going too fast, though. In the olden days, this would take a little while to render all the text, right? And so it would be raining down rain. They're all actually links. You click through, and this image of rain loads, and you saw how it went down? Well, imagine this at dial-up speeds. The rain would just be slowly cascading down your screen, right? Again, Jody's doing this sort of concrete manifestation of a piece. The thing they're misusing here is speed. Speed was, for the engineers, an impediment. But for the artist, the speed was the feature. And the reason the artist could see that speed was a feature is because they're just misusing something that was there that had no value to anybody else. But slowness can be a feature. Engineers have engineered slowness into computers. You guys remember these turbo buttons on these machines? Does anybody here remember that? Anybody old enough to remember? Yeah, turbo buttons. Engineering slowness, keeping your machine slow enough to run at 4.77 megahertz to run old software. So there's value in slowness, right? And engineers will make things slow when the value proposition is clear. The artists will make things slow, they'll misuse things when the value proposition is not. The last Jody piece I want to look at, we're not going to look at, because this has not been, I have not been able to find this anywhere. But again, creative misuse. Netscape 1.1 had a bug in it, and the bug created a situation where you could have one head and multiple bodies. And the way that Netscape 1.1 would render that is it would render it one body at a time. And so the people at Jody decided, hey, we could animate with that. And this was before Flash. It was before JavaScript. This was the original web animation. It was before animated GIFs. And so for about 11 months, there was a whole thing of, there's a few artists working on the web that were misusing this bug, leveraging it to create these animations. Of course, they were obsolete within 11 months, of course. And so what we see is a situation where this misuse can, on one hand, perhaps hasten your obsolescence, the work that you're making. Artists can actually hasten things, hasten the momentum of or the value of an object or a implementation. But they can also, when they're kind of working at the edge, influence the system itself, which is the next thing I want to look at. So this is an early animation, 1963. It's one of the first known computer animations. This is what it looks like as it goes around. And of course, what the engineers at Bell Labs were doing in the 60s is they thought, well, this is going to be great because we have all these models of various things in time, and we can finally see what they look like. We can finally see what an orbiting body looks like around a satellite there. And so they saw, of course, immediately the value proposition in this, but then they did something kind of weird at Bell Labs. They brought in the artists. And the artists said, oh, that's interesting. Let's do some weird stuff with it. And when Lillian Schwartz came in, she had some pretty interesting ideas about how animation should work with computers. And so around the time that that first image, or that first animation that I showed came about, Ken Knowlton, who also worked at Bell Labs, started on his DSL, domain-specific language, for animation called Bflix. And they actually did a number of art pieces together with Stan Vanderbeek before Lillian Schwartz came in. But she looked at it, and she's like, there's one really big problem with this. She identified the problem, the language, right away. And it's the fact that like any of the generative work that you could like create within Bflix, it didn't hold from frame to frame. Okay, so animation is all about one frame at a time, right? And you could do that in Bflix, but if you wanted to generate something, that information didn't actually move between the frames. And so she saw that as a problem, and she designed and helped implement this Explorer language. Let's see if this is loaded. Unfortunately, I can't grab her stuff off the web. So this is her website. It's an awesome website. I think she got Lillian.com, which is amazing. Yeah, so let's watch a second of this. There's a little sound. See if it comes through. The sound was also done at Bell Labs. This is what it looked like. Yeah. Pardon the compression. Yeah, it should come with a seizure warning too. Sorry about that. But this is, I mean, I kind of love this piece as well. And all of these shapes are generated. And so if you ran the film multiple times, it would come back with multiple different iterations here. But of course, it was only meant to be run once because it was actually meant to be print to film, right? And so what came out of that creative misuse were features. So you create an animation DSL, you create the most complete and thorough and brilliant animation DSL known to humankind, which is really what Ken Knowlton did because he created the first one. So there was no other one to compete with. And of course some artist is going to come in and ruin that. That's their job, right? Their job is to subvert. And she says, well, this could be better because of this. So no matter what you do with your DSL, and I'm sure anybody who has made a DSL for any purpose, someone's going to come in and mess it all up, be like, I want to expand it this way, and you're like, but that's not the intention, and then then they fork it, and they create their own DSL, and all of a sudden, we have 10,000 node packages. But misuse can also be beneficial and get long-term features. In fact, these features were used at Bell Labs for tests in vision, or experiments with vision, experiments with animation, and so forth and so on that were educational. So yeah, it actually had also practical engineering purposes and scientific purposes as well. This is a piece by David M. That he did at the Jet Propulsion Laboratory, which is a NASA-run space in California in the 1970s. And this particular piece, he did a number of interesting stills. This particular piece is notable because of how these grids kind of curve and undulate. And the reality is of course, that was a bug. That was not supposed to come out that way. But he's like, hey, this is pretty freaking great. And then these engineers do what they do, and they fixed it. They fixed the bug. And so what did he do? He added in a randomized routine, right? And what he's pointing at is that misuse, of course, is this very human thing, the random thing, the messiness. See, engineering, the goal is certainty. The goal, I mean, we never get there, but we want to know how long this bridge is going to stand up, right? We want to know that this formula is going to give us the correct, this algorithm is going to give us the correct answer every time it executes. Okay, we want to have that certainty. But then you live real life, and you don't get that, okay? You get all this great stuff called serendipity, and you get all this other horrible stuff called accidents, and that's it. That's what you have. You don't get the engineering part. And that's why people respond to this stuff. That's why the artists will come back in and add this uncertainty, because they can see ways to make the product, to make the experience more human, because art is really reflecting the human experience, and engineering is reflecting some idealized experience. It's a piece by Deanna Smith called Francine, done this year. That is done in CSS by hand. So she paints not with a some sort of pen or something like that. This is done. This is mostly hand coded. Here's her Git repository for Francine. That's what it looks like. It's quite remarkable. Anyway, yeah, you can see just how crazy all of this is. If you load, yeah, it's all one line, of course, one line of code. It's brilliant. There it is, right? If I had one recommendation, it'd be like, comment your code. I can't read this. No, obviously not. Okay, so yeah, quite remarkable. And the thing about this piece in 2018, I've been looking at all this stuff from the 70s and 80s with you guys, with y'all, and here we see, like, in 2018, it's the same stuff, just decades later. Because people are just going to do this. It is just the reality of software. It is just the reality of engineering. People are going to misuse it because they like to, right? Or because they don't know any better and they make an accident, right? So one's art, one's an accident in life, right? But this is reality, and it's up to engineers to accept the reality and see how we can leverage this reality. This is one of my favorite things that she showed when I saw her talk recently. She ran this through older CSS engines. And I was really very impressed with this. The fact that the system still kind of holds up, right? The form is still there, the intention is still there. Even as we go all the way back and her face kind of slides off into her body, it's still there. And misuse, coloring, working at the edges and eating at the edges. it can give us really actually sound and practical reflections about the system itself. It can tell us if the system is robust. That's the thing that was so impressive to me about the CSS example was, wow, it's that consistent that we can still get that kind of form as we go back through the previous engines. I mean, people complain about CSS all the time, but that's quite remarkable. We can also see how expressive it is. Obviously, CSS is so much more expressive than it used to be. Right? The last piece I want to look at today is this piece by Eduardo Katz. He is a Brazilian, and he was working in video text, which is implemented on the Minitel network in Brazil. So the Minitel network was another non-internet network. Bring it up here. Was another non-internet network. This one, it was very common in France, various places in Europe. It was also in Brazil. This is what it looked like. This is actually a Minitel terminal. So we're getting the experience of what it would have been like in 1985. And what we have is sort of like this A that kind of comes out of the background, and then these little stars around it. And if you look closely, of course, that fills out the rest of the word of abracadabra. And it's an interactive piece in the sense that you have to go out, presumably you're in your home or you're at a public place with these network terminals, and you have to go out and grab the piece, download it, run the piece, and then it will keep looping. It's called re-abracadabra, not just one abracadabra. So, so he made this kind of clever piece of neo-concrete poetry, right? So concrete poetry is poetry that is reflective of the material that it is pointing at. Poetry describes something. Concrete poetry also looks like the thing that it is describing. So that's why it's situated this way. And the thing is, this particular piece, and actually all of these pieces that are older, they bring up a really interesting question around digital preservation. These systems, of course, are very hard to maintain. Unlike the Mona Lisa, which was referred to earlier, and it just keeps coming down from century to century to century. I mean, we can't even get stuff working from 40 years ago because engineers didn't design it to be long-lasting. They designed it to get it done. Ship it, remember? Okay? So what we actually have is a piece where its essence has changed from an art perspective. It was something that was a piece of what is called telematic art. Telematic art has a long history from mail art to fax machines to email, where artists would send things over the wire, and that was part of the piece. In re-abracadabra, the Minitel network is gone, and that poor terminal is connecting to a thing, a reality that it thinks is the Minitel network, but it's just a simulation. Okay? And it's really, of course, removed from its original intent. It's a pastiche because it does not have the network aspect involved. It's actually now, technically, it's just computer animation. It's not telematic at all. And the thing about having a piece like that, where its essence still seems the same, but something material has changed about it, its purpose becomes, well, as unclear as it ever was. I mean, why did Eduardo Katz make that? I mean, what was the purpose of that art piece, right? It has no clear application. It has no purpose. In fact, its essence has changed, right? And what's happening here is, of course, this is not the thing. This is not the pipe. This is a simulation of something that someone experienced in the 80s that points to the actual art piece of neo-concrete poetry. So this is not the pipe. It points to the pipe. This is not the experience we had in 1985 in Brazil when we got the thing, or when we got re-abracadabra. It is a computer animation that points to the original experience. So its essence has changed, its purpose is obfuscated. The fact is, it's a pastiche of what it was. It's still valuable, and it's still art. We can still see that as art. We can still point to that and say, I get all that, it's not really what it was, but it's still art, right? And the expression has changed only because the technology changed around it. So coming back around then, we've circled around this whole question about what is technology, and we get caught up on that screen, that terminal, the network. Is that the technology? Okay, is that technology? The problem that we have as engineers too often is we get blinded by the screen, the terminal, the purpose, all this other stuff, because that's what we think the technology is. It's that. But that Minitel screen is still able to communicate and to show this place and time that is still meaningful and it's still art. So it can't be just the screen, it can't be just the network, it can't be just the terminal itself and the keyboard. I'd argue that technology is the entire system of engineering. And so that includes all the things that you touch every day, the code, all the things you think about all the time, the design, all the things that underlie it, the physics that make it possible. But it also includes the social relationships, because that also makes this possible. It also includes the education, the background of the people that you work with. It also includes the culture. That's all built into the technology. Technology cannot be removed from culture. And the thing that artists are good at, the one thing they're good at besides not making money, is culture. Is culture. So I guess the only thing is bringing artists in early, talking to artists, making art a part of your life. That's the ask. That will make you a better engineer, because culture is part of everything that you make, whether you like it or not. Thank you.